Hello. So this is a video about the vegetation detailing that I've added to the terrain. So if I hit play button, you can see here I've added. Let's just move away from these wobbly characters. So you can see the grass blades that I've added wobbling in the breeze using my grass shader. I have a number of different grass blade shapes. They're deliberately really simple. Um, and this is a blade that starts narrow and gets a little bit wider as it goes up. They're just Blender. I use Blender just to make them. And the the idea here was to use as few vertices as possible, just to keep the performance up. And there's a few others in here, so I've made a sort of a reed, and the reed wiggles slightly differently. As you can see, it kinks in the middle, but the top of it stays aligned with the base, and it gives it a quite a good effect for, like, if it's in water, where the surface of the water would be moving the body of the reed and stuff. Anyway, it wiggles in a different way, and I thought it was cool. Um, yes, it was a mistake with my mesh, and then I decided I'd keep it because it was kind of weird. So you can see the kind of coppery color that I'm using for most of them. The reeds are a little bit different color, and there are a number of other meshes that I'm using. So if I look in my grass meshes, I've tried experimenting with some different shapes, some 3D clusters of these fronds. Um, Generally speaking, they didn't look as good, in my opinion, and more importantly, the performance wasn't any better for the kind of density of ground coverage that I was getting. 100 frames or so a second on quite a high spec machine, but if we remove the scene view and just have the game playing instead, you can see we're up to um, much better frame rates, and as that caches, it will improve. Generally, it's around 300 or so a lot of the time, and at the moment it's down in the 200s. Something to keep in mind, something to watch. You can also see here I've added some stones and rocks and stones um, are distributed all over the place um, according to a procedure, as are the blades of grass. So here in this area you can see we've got the wiggly reeds, we've got the coppery fronds in the background going up the hill, but also some little small jobbies here, small grass blades, um, and again very few vertices, just enough to give a little wiggly grass blade variation from the bigger ones, and that's it. The stones are simply the same model stone, and I've gone for a very low poly number of vertices, reduce the number of vertices as much as I can, while still looking rock-like. And I'm pretty pleased with the rocks. I think they look decent. Whoops, sorry. Um, so there they are. They're being used at bigger size, and I think generally there's enough detail on them that when their position is randomized, they don't look too similar um, to each other. Um, so what can I show you? I'm just thinking that looks like a fairly large rock at the top of this hill. So just going to go up to that before I then go through the how I distributed the grass, because grass and rock details I didn't want to hand paint everything on because it's quite a big landscape, and I wanted there to be a reason for why things are in a certain position, and I felt that trying to consistently keep in mind all the factors that would apply to the position of rocks and things would be quite hard to do and make any good progress. So here you can see the same rock model but scaled up much bigger, and it still looks pretty good. So I'm very pleased with that. There's some sort of artifacting on its surface here due to its scale and the normal texture that I'm applying to it. So all the rocks from the smallest to the biggest are currently using a rock material with a normal map, which is this one for its texture. And depending on the lighting conditions, where the sun is in the sky mainly, and the size of the rock, sometimes you get this kind of artifacting. But I don't think it looks too bad actually. I think I'll just live with it for now. If it bothers me in the future, I couldn't, and I know the solution is simply to provide a different normal map that would be of appropriate scale. But because I'm trying to minimize the number of prefabs that I'm using, these are in fact the same prefab that's being placed just at different scales. So if I go into, for example, a terrain tile, they all have these prefabs, the grass blades, the reeds, and the rocks, and the difference between them is simply the range of size that each prefab can use. So when the algorithm places them, it randomizes between those the minimum and maximum sizes that you've stipulated for each one. So I've got about 56 tiles, and each tile is 1,000 by 1,000. So the placing all of those by hand was a task I didn't want to do. So I've done it procedurally. So let's look at that now. I'll just park myself here. So I've added a detail manager object which I could attach a script to, and during the awake method, if it's got run at start ticked, then it will run my procedural detail painter script. And I've got a couple of options I've added for clearing the detail layer when it starts. So you add a detail, drag one of these details from your prefabs, grass or rocks or whatever, into this slot. And if you want to clear the existing ones, if your terrain already has some of this one in use, then checking this either at the end or at the start or both allows you to do that. Otherwise, what you will now define for this rock with your pixel step and your minimum size, maximum size, noise seed, noise spread, all of these factors will redefine that layer with the new values for any new items being placed. So it means you can produce stuff. You can have a go and then additively run it again to do some more or replace a whole lot. So these are my controls that I've got. So pixel step for stepping across the landscape. The tiles have a pixel definition of about 1,000, or it might be 1,024 or something. I think it's 1,000. So I can step, if I step one pixel at a time across the terrain maps, takes a very long time to do. But if you bump it to like 5 pixels, stepping in steps of 5 pixels, it doesn't take too long. So I've tried lots of values using like a pixel step of 10, which is nice and quick, to see is the grass coverage going in the right places, is my algorithm and logic working, and then once I'm happy that I've got my code working and it's placing things in the right where I intend them to be, then I pull the pixel step right down to like 1 and then run it to do a detailed sweep of the terrain and place stuff. Maximum density is currently set to 1, but this is any pixel on the landscape has a maximum number of details that can be put on it. And the fog's coming in at the night time. Looks quite good. So this can be, I think it's 32 by standard. You can actually change it in the pipeline, in the URP render pipeline settings to be higher than that. But obviously that will affect performance. So I'm just leaving things with the default maximum of 32. What I've noticed is that if I place items in a layer, no single layer can use all 32 in the array. It can't use the whole 32 items for its own details. It seems to have a maximum of 14. So yeah, not really sure why, but that seems to be the actual reality. So setting it beyond 14 has no increase. I can't increase the density of this grass by sliding it up to 32. Beyond 14, it doesn't make any difference. I think what it is that you could have another 14 of a different detail, and that would leave you, what's that, 28? So that would leave you 4 slots left for another detail. So it would allow you to all 32 has to service all the different detail layers. I think that's the idea. I could be wrong. Probability, that's just my own thing. So as I'm stepping over the landscape, every pixel, it checks this probability and it rolls a dice effectively and says, have I rolled a number bigger than this probability? If so, then we'll carry on. Otherwise, we'll put a detail at this position. So it allows me to add otherwise it would become like a checkerboard where you'd have a rock at every 5th pixel or something like that. So it adds a bit of randomness. The max min height of the actual rock is controlled here. That's just the parameters you'd see on a standard detail when you're adding it to a terrain. So that's just, I've exposed them here, but they get plugged into the normal places. These multipliers here are then my own, so I have an algorithm that places details on the map, or places grass on the map, and looks at a number of factors in deciding whether grass should be, how much grass should be at that location. And the factors are water, sunlight, temperature, and nutrients. So it's like the richness of the ground. Temperature is, if you like, it's a proxy for elevation, because as the higher up you go, the colder it gets, and that affects growth of plant life. Sunlight, well, that's obvious. The place is getting more sunfall across the day. You'd expect there to be more vegetation or richer vegetation. And water, obviously things need water, but you can have too much. So if you're under the water table, or under the water surface in a lake or a river, you've got no drainage, but you've got plenty of water. So there's a sort of more complicated aspects to water. I have these multipliers. They let me just empirically play with what the algorithm's giving me until I find something that works. And when you're placing just a rock or something, they have no impact at all. They only have an impact on reeds and grass, and it figures out whether it's a rock or it's reeds and grass just by analysing the name of the detail and looking for a keyword like rock or grass or reeds. So it's not very clever. That's how it works. It's good enough. So in terms of how we tell the algorithm, okay, so this is how sensitive we should be to sunlight for this. I should put I should put a grass one in there. So let's pretend. So let's pretend we're looking at grass. So how this medium-sized grass, how sensitive should it be to water, sunlight, temperature, nutrients? We can put some maps in, and this allowed me to create some maps here as snapshots of the land at different times of day to capture the light. So if I open these, let me see. I think that will do. There we go. So I have 6 o'clock. That's what the terrain looks like. 6 a.m. in the morning. 9 a.m. it looks like that. Midday, 3 o'clock, 6 o'clock in the evening. So from that, I was able to combine them all and get an average, which gives me my average sunlight across the day, and then normalized it from 0 to 1 or black to white. And that's my sunlight map that I'm using in here. Wind map is actually so wind affects growth, and it comes into one of the checks I'm doing, and so I have a similar wind map, which I achieved by just putting a light source at the side that I wanted to be represent the prevailing wind direction. And so that then lights up the landscape, and all the faces that are windward faces get brightened, and all the others are in shadow, and that effectively is my lookup for, is this pixel on the landscape subjected to wind very often. So that goes into that's my wind map. Development map, I've stopped using. I used it to mark out roads and village positions, housing positions, buildings, and fields. But I've decided, and it worked fine for that. It just basically it marks out positions as not being available, which was fine. But then I decided I don't actually want to position the buildings and roads first. I want to do the natural landscape as it would have been before any human settlement or development, because most likely you would actually look at the lie of the land and how it is in its natural state in order to decide where you would put your roads. So it'd be the other way around. You'd decide where to build your homesteads and buildings based on how many trees you had to cut down or that kind of thing. So I've decided to leave that one blank and not use that, even though the algorithm can work with one if you have one. And then the soil map, which tells you where's my soil map? There we go. Dragged in the wrong one, the meta one. Soil map. That's the one. So this is funky color. So basically, I'm making use of the 3 channels, red, green, and blue, within the one map to describe 3 different parameters ranging from low to high. Red, loosely I've used the red, green, blue RGB to represent things beginning with that letter. So R for rock. So the more red it is, the more red a pixel is on this map, then the more there is rock at the surface, or the closer to the surface that you have rock. So I was able to just take the earlier map snapshot from above of the model of the terrain, and then just color over it on another layer in GIMP, wherever there's rock basically, or mountains. So I've done that. Then green is what's green? Green is for grain, as in grain size of soil particles. So if you have a very clay soil, it doesn't drain very well, but sand and gravel drains exceedingly fast. So grain soil comes into the algorithm, and this map allows me to paint on green for gravelly locations. So I'd gone round with green on the mountainous tops and on the riverbeds where you get more granular deposits. Then in the blue channel, blue stands for biological value, aka nutrients in the soil, and I've painted on blue in areas where I thought, well, you know, rivers tend to deposit lots of, in alluvial plains. You tend to have quite rich um, um, what's the word? Organics in the soil. Um, Rocky areas tend to be very barren. They have mineral content, but not much. Most of it's run down, and the rain carries it all down into the valleys, and the low-lying areas end up with all the deposits of minerals and organics. So that's why I've gone. That was the kind of guiding idea for my map there. So that's my map that feeds into the soil map, and I have a water table set at 2 for where the rivers and all the water in my environment is set at 2 meters at the moment. And then slope stability, because this affects rocks. So I have a button here for rocks only below slopes. This is basically the premise that in positioning rocks fall down slopes that are steep and collect at the bottom of the slope. However, that's not the only story, because sometimes you get rocks and stones, on the flatter areas that have been, I suppose, deposited there millions of years ago when glaciers roamed the earth or something, and transported everything. The other thing is erosion, that rock in the possibly in the bedrock or whatever has come to the surface through erosion or something. I'm not really sure. ChatGPT wasn't particularly helpful on positioning of rocks and stuff. There didn't seem to be any great trends for where you find rocks. So it really has mainly been guided by collecting at the bottom of slopes and slope stability and particle size, where you've got crumbly soils. The rocks would easily come to the surface, whereas in clays and stuff they might stay a bit buried. And I've set what's considered to be crumbly on my map, my soil map, as a halfway 0.5 value. So fairly primitive, but at least I've got some rules that mean that the positioning of everything is kind of formula driven and consistent across the landscape, hopefully, and makes some sense. So that's it. I've also added a normal texture to the ground, which gives a kind of muddy texture, which looks quite good to the sand, and I think it looks good in most places actually. So that was a quick win. Not much to say about that. I could show you the Visual Studio Code for my for my placement procedural detail painter. Wherever it is gone, there it is. It's not a work of art, this, by any stretch. I've fairly bashed it together. So we've got these options on the UI and a few internal variables. Then we've got the monobehaviour awake, and I'm not using update. It just runs in awake and then it's finished. And on application quit, just in case we're clearing a layer, if we've got clear at end ticked, it can whiz through the terrains in in the list and remove details from them. So most of it happens in the awake, or it all happens in the awake. So if it's not ticked run at start, then it doesn't carry on; it just exits. So first of all, we get a list of all the terrains by finding objects that have a terrain component, and we create an empty array of detail layers that match the same number. And then we go through, iterate through all the terrains that we found, and do the same thing to each of them. So we've got a couple of public variables here, global variables in the class here. So we set them to the properties of this particular terrain tile. And the one we're going to work with a lot is the terrain data. That's where you store the actual position of things like grass blades or stones and rocks. If the detail that we're adding here, so in this one it's the medium grass, we're going to add this into this terrain tile if it doesn't already have it defined. So that's the in the terrain tile here. This is the prototypes defined in it. So if it finds it already, it doesn't need to add it in. But if it's not there, it's going to add it in. Then we get the different layers for these prototypes. So each prototype has what Unity calls a layer. There seems to be inconsistency. I don't particularly like its naming convention. Anyway, the layer is essentially an array of details about the placement of so let's take this first prototype. There will be a layer, aka an array, that says for every single pixel whether there's one of these on it or not, or in fact whether there's 12 or 14 or 32 of them on that pixel, and what size scale version of this prefab it exists at that location. So that's what the detail layers are. And what we're going to do is we're going to add a new detailed layer, or in other words a new array for the grass that we're adding now to each terrain tile. So we do that to all the terrain tiles. So let's go and see what that does. So we need to know the position of the tile in the world, and essentially we're going to step over the pixels in the tile. So if there's already a array or a layer or a detail map, whatever you want to call it, then we use that. But if there isn't, or if we're clearing it at the start, then we just create a new blank array of the right that matches the pixel size, which is the terrain data detail width and detail height. So we step over the tiles detail map, going from the I'm just thinking about those, whether there's any confusion. I'll have to come back and think about that. So we go from the terrain tile has a detail resolution or a pixel resolution. So we're going to loop across its pixels using our pixel step that currently here is 20. We're going to do the same in the Z direction, and I've got various tested things that I was doing with cubes just to make sure my positioning things that getting the elevation and stuff was getting it correctly, and just visually checking everything using a cube. So that's why that's all remarked out. Don't think we're actually using these anymore. So So essentially we roll a dice, as it were, and if it's greater than the value here in our probability of 0.01, which it most probably will be because that's a very small chance, then we're going to just continue to try the next pixel. But if it is less than this probability, then we want to maybe put some grass there according to this. So how much? So we need to find out how much grass should go there. We work it out in this calculator method, and then we add it to our layer or our pixel map to say at this pixel we will have this amount of our detail. Note the reversal of maps. So arrays in Unity are back to front compared to Cartesian axes in the real world. So that can be a gotcha. So that's worth knowing. And then having built up, having assigned details to pixels that should have items on them, we then take this detail map and we have to shove it into Unity's terrain data so that it will be saved in there. So we say in the terrain data set the detail layer, so it's this terminology of a layer for storing this array. And we shove it in there, and we're saying that this array relates to the particular prototype, in our case the medium grass thing. So that's it. And then terrain flush is just making sure that any stuff we've just done gets flushed through to the editor, or the graphics output is updated for it. And that's it. So that is a simple enough loop. And then of course the devil's in the detail in this detail density calculator, and essentially it goes through my method for grass, or if the thing contains rock, it goes through my method for rock likelihood or probability. And the only thing of interest here for the rock one is that wherever I place a rock, I don't want there to be wiggly grass going through the rock, so I remove any grass at this pixel location and surrounding it to make sure that that doesn't happen. So there we are. I don't think I want to go into any of this, otherwise the video is going to be exceedingly longer than it already is. But we'll just say, we'll stop at this bit, that basically I look at water availability at that location, sunlight at that location, soil, and temperature, which is really a surrogate for altitude or elevation, and the space availability, but I'm not using that one at the moment. Soil calculator is a little bit multifaceted in that it looks at the quality of the soil from the soil maps, looks at soil stability and drainage, so it's like particle size and elevation and stuff like that. So various empirically based pseudoscience kind of factors have gone into that to create my algorithm. So I'll leave it there. But so far, so good, and it seems to be working reasonably well. I don't know if in the scene viewer I might be able to zoom into somewhere with if I find I'm just looking to see if I can find a kind of a slope with a bunch of rocks beneath it. I didn't want too many rocks on the landscape. I can always add add rocks and details later on. These are massive. They don't seem that big when I'm zooming here in the terrain and in the scene view, but they're really big. So you don't want too many of those. You want the tiny ones more often. And the purpose of having all the little rocks and details really is so that when you're moving, you get a sense of progression. So if you've got a rock or something that you're passing, it gives you a sense of how fast you're travelling, which is important to gameplay, to have those factors. And there's one of the big rocks in the distance. You don't want those everywhere. It's not very realistic. So I think that's good enough for now. And the interesting colour grass that may change, but I quite like it for now. Right, end of video.